Well, I think, well, I'm Albert, and I'm here on behalf of the um, DARWIN EU Coordination Center and all the co-authors. So we published a paper on how we think about phenotyping in DARWIN EU. So first, I need to say that this is my views and not those of the EMA. So we published this paper on the 12th of November, and with all these co-authors, all part of DARWIN EU or DMA. And why do we need a standardized procedure for phenotyping? Basically, this is what we describe here is the standardized procedure we're using for phenotyping in DARWIN EU. So we wanted to increase transparency, reproducibility, and reliability. Everyone that has done any phenotyping that I'm sure many of you have done in the call know how difficult it is to be, how many steps you need to go, how iterative process it is, and how difficult it is to make it reproducible, transparent, reliable, and how much time it takes to do it right. So in DARWIN EU, we need to do loads of phenotypes. So it's very important for us that we can do this in a fast and way and quick way without losing this transparency and reliability. So the idea is that we wanted also to be able to store metadata, and we had a big focus on traceability. We want to know for each of the phenotypes what decisions were made, who made those decisions, and why did they make the decisions. So everything needs to be logged, the decisions, the responsible person, and the reasoning behind those decisions, and everything thinking about the data network in DARWIN EU, the strengths and the catalog of standard analytics. And how we did this is in co-creation with the EMA. So we had a phenotyping work group between DARWIN and the EMA, and we had regular meetings with people that work in real world data, but also with a lot of people from the EMA that work on pharmacovigilance that had to buy in and that work with us to make the process useful for everyone. This is a little bit of how the process works. It's an idea of how the process works, and we build this process that, of course, it's still ongoing. We're still changing things. We're still working on it. And we also built a tool that is a repository of concept sets and cohorts, but also it's a tool to track this process from start to end. The process starts, as you will see in the paper, if you want more information, but starts with a proposal form. So someone requests a certain phenotype, diabetes, any phenotype they want, and they give information about them. And also, we write a clinical description. So as you know, this is the first step on most phenotyping is writing this clinical description, and this is written by clinical experts in conjunction with the requester, with the PI of the study usually. And here we add a phenotyping plan that it's the logic. As you know, to the phenotype, maybe we need different concept sets. We need a logic to these concept sets to generate the cohort. And if we need more than one variant of the to test of these cohorts, this is done here. The next step is to search the database of cohorts to see if somebody has already done this cohort or this phenotype, and assess if that is if that is suitable, right? So we search first for cohorts. If we find a cohort for the phenotype we're interested in, we then evaluate if it's done in the same vocabulary version we're interested in, what data pairs has this been run, if it focuses on the index date or the specificity or the sensitivity, so we know we assess if this is suitable for our new study. If not, we do the same with the concept sets. We evaluate if have been used before, if they're useful or not, and if not, we need to go and do it from the start. And it starts by generating a concept set. We try to follow a systematic generation using keywords like we would do in a systematic search, and we store these keywords so it is kind of reproducible to generate, to get into the same concept set from the start from those keywords. We store also vocabulary version and every step that we follow for it. Then this concept set is turned into the whole list of codes, and this is reviewed by someone with a clinical background or an expert on it, usually 2 people, and then a third to decide on the ties. And of course, the deck, this tool is built so it can you can review, and you can see the different versions that have been created, what are the difference, who did it, and all this is stored inside the deck. And then once you have this, you go to Atlas, you generate your cohort, and you run cohort diagnostics. But then you can go back to the deck and store in the deck the review of cohort diagnostics. So you would store here in which database is done, what did you find in cohort diagnostics, how does it look against your clinical description, so the literature known to that point, and of course the recommendation whether this cohort is ready to go for the study or you need to do some changes to make it better, or it's actually not usable. That is another outcome. In the paper, we also apply this process to 2 phenotypes. Very simple, just a concept set base cohort in a way, pancreatic cancer and lupus. And if you want to know more, you can message me to my email or look at the paper, and I'm happy to take any questions later. Thank you.